we are going to do is we're going to learn and practice how do we show those representations when they give it to us, as they did here in number 1. They give it to us as a set of ordered pairs. How can we show that in a table, graph, and as a mapping diagram? Okay. So when we put them in the table, here's what we want to do. We want to put them in the table. We want the x values to go from least to greatest. Okay, we want the x values to go from least to greatest because it actually makes it easier to put them into a graph that way. So you want to look at those. So you want to look at the x values of your ordered pairs, and you want to decide, are they already in numerical order from least to greatest? They're not, are they? Okay, so let's put them in the table, though, that way. So what's the smallest x value? -2. Well, when we use that -2, we have to put the y value that goes with it. Okay, we don't put the y's in numerical order. We're not showing the domain and range here. We're showing the ordered pairs in a table. Okay, so the y value has to come along with it. If we use that point up, then we have now going to take the y value with it. Okay, what should we put as our next one? Okay, -1, 1. So we've used that one up. And we get another one that has an x value of -1, so we'll do that one also. And that one has a y value of -2. And then we have our last ordered pair that has an x value of 3 and a y value of 1. Okay, so we have to be really careful though, because we're not writing domain and range necessarily. We're not writing the sets of domain and range. We're actually putting the ordered pairs, showing their relationship in a table. So the y values have to come along with the x value they were with. Okay, so there's our table. Now go ahead and graph those 4 ordered pairs on your graph. And you don't have to put their ordered pair names beside them, that's okay. You can just graph the ordered pairs. And even though it isn't going to ask us this question, I want us to stop right now and evaluate. Do you think this relation can also be called a function? Did you say no? Okay, why not, Julia?
Because there's 2 sums for the x value.
Okay, which x value has 2 different y values? Which x value? -1 has 2 different y values. And notice how it shows on the graph. What happens on the graph when it's not a function? They're on the same what kind of line? Vertical. If you have points above or below each other, that means there's an x value that's got more than one y value, because on a vertical line, all the x values are the same. So we got this point and that point that are falling on a vertical imaginary line, so that can't be a function then. Okay, when we map them, now here's like, okay, go ahead.
Well, what happens if they're going like this across each other?
Okay, what if they're horizontally across from each other? Okay, let's pretend this point wasn't here and just those guys were horizontally across from each other. Would it be a function? So I'm taking this point away and I just have those 3. Would that be a function? Yes, because each x value still only has it still has just one y value. When x is -2, it only has one y. When x is -1, remember we took this one off, it only has one y value. When x is 3, it only has one y value. So here's the thing that does mess up students when it comes to functions. They think that 2 different x values can't share the same y value, but they can. 2 different x values, what matters is, do each of those x values have their own y value, only one y value? Doesn't matter if it's the same y as another one, does it just have that one y value? So when they're horizontally across from each other like that, Cody, then that does not disqualify it as a function. Okay? Only vertically, because now we're sharing that same x has more than one y value. When you do your mapping diagram, this is when you can think like the domain. We do not do repeats in the domain. We do not do repeats in the range. We start with the domain on the left, we have the range on the right, we do it in numerical order from least to greatest. So if you can kind of think of this as we're in our first part of our mapping diagram here, we're going to put our domain. So what's our domain?
-2, -1, and 3.
Yeah, and we don't repeat that -1. Least to greatest, don't repeat any. So that first part of our mapping diagram, the left side, really ends up being our domain, and the other side is our range. What's our range? In least to greatest, -2, -1,
5.
and 5. We have 2 ones, but we don't need to repeat that other one, so we just write it one time, okay? And now we map. This is when you have to make sure you do a good job of mapping. That -2 gets mapped to what number? To the 5. So we draw a line with an arrow going to 5. That -1 gets mapped to 1 and to -2. So it's going to go up to this -2 and it's going to come over here to this 1. It's got 2 arrows coming out from it, that -1 does. And 3 gets mapped to +1. Okay. So they can get kind of messy, especially on my smart board here, but hopefully yours is a little neater. Okay, I want you to go try number 2 now on your own. Okay, go to number 2 on your own. You're given a set of ordered pairs, put them in a table, graph your points, map your points. Okay, I haven't gone any further than just filling in the table. Because I want to stop right now and I want to ask this question. What, if they were asking us if this was a function or not, what would we say?
Yes.
Yeah? So, just looking at the table, how can you tell from the table that it is a function? Cody?
Just each x value has only one y value.
Yeah. Each x value only has one y value. Does it matter that they all have the same y value? No. They each only have one. That's what matters. So it's very tempting, especially when you look at that table, to say, oh, there's all those 3's. This can't be a function. But then what happened when you graphed it? They're all on a, what kind of a line do they, they're lining up in a horizontal pattern, aren't they? And what did we say? When there are no points above or below each other that are sharing the same x value, that means it is a function. Are there any points above or below any of those? No. Okay, and then in the mapping diagram, our domain is what? 1, 2, 3, 4, and 5. And what's our range? 3. We only write it one time, don't we? And then every one of those are mapped to that 3. So even though that 3 has all those arrows coming at it, each of the x values only has one line coming from it, doesn't it? One mapping line coming out from it. So it is a function. Each x value only gets mapped to one y value. So any questions on either of those before we move down and do our bottom 3 things here? Okay, let's go take a look at what we're supposed to do. Give the domain and range of each relation. Tell whether the relation is a function. Explain. Okay, they give us all kinds of room to do this, so. Number 3 is a continuous graph. Can we give a domain and a range as distinct numbers? No, this is where we have to do our what? How do we write domain and range on a continuous graph? Compound inequalities, don't we? Okay, so we need endpoints, don't we? Let's identify those endpoints first of all. Let's go and say, what is the endpoint here? What is that one's name? So what's this one down here? 0, 0. Okay, what's this one? 4, 4. So, there's a whole bunch of ordered pairs on that line. We can't even begin to name all of them in our domain and in our range. So we are going to have to do our compound inequality. So our domain, they already have our capital D colon there. So what, Cody?
It's an and inequality, so you go 0 is less than or equal to x, and less than to equal to 4.
Okay, and then our fancy set notation, right? Okay, good job. Okay, what's the range?
Same thing.
Same thing, okay? Right. 0 is less than or equal to x is less than or equal to 4.
Except you have to put the y instead of the x.
Oh, because the range is made up of
The y-axis.
y values, not the x values. Okay, so we got to change that x out in the range to a y. So the smallest x value was 0, the largest x value was 4. So we started with 0, we ended with 4. The smallest y value was 0, the highest y value was 4, so we started with 0, ended with 4. Is this a function?
Yes.
Okay. Why? Cody?
Each x value in that domain have exactly one x value.
Has exactly what?
One y value.
Each x value has exactly one y value. And does the graph show that? Does the graph support that each x value has exactly one y value? How does the graph support it? What did we say earlier about graphs? What's going to be true if you have a function in a graph, Aurora?
If you have a function, you don't have two points on one vertical line.
There you go. You don't have 2 points on one vertical line. Any vertical line you would imagine going through that graph would not have more than 1 point on it, would it? Okay, good job. Okay, let's look at the next one. What's the domain for number 4? The domain is always on the left. Okay, so our domain is what, Noah? What's our domain?
8 is less than or greater than x.
Oh, it can only be one or the other, by the way. I think you meant equal to. Okay, x. Is that it?
Is less than or greater than 9.
Did you mean equal to again?
Yeah.
Okay. Okay, how do we feel about that? Do we like that domain? Why not? Because it's not a graph? Well, that might be eventually a reason why we wouldn't write it that way. It's because the graph, we don't have a graph to support that, but Julia?
Or you just only use the inequality when it's a graph.
Okay, not necessarily, so not necessarily be only when it's a graph. Okay, I don't want you to think that, but I kind of like your thought process that's going on. Cody?
When there's only 2 in the domain, you really, okay, what we're saying right there where you put the and inequalities in, that anything equal to or in between those 2 numbers is equal to a range, which we don't have a 7 in our domain. So
You mean domain, right?
can't do
Or we don't have, no, 7 wouldn't be in here either. Greater than or equal to
Oh.
8. But how about 8.5? Is 8.5 in our mapping diagram?
No.
Is 8 3/4, 8 1/10? No. So we can't write it as a compound inequality. We do have to write this one as a just a discrete points. It says the x values are 8 and 9. No compound inequality for that one. What's the range? Least to greatest.
-9, -6, -4, -3.
Okay, -9, -6, -4, -3. Okay, is this a function? No. Okay, why not? What's the reason? Calvin? They told you it's not a function. Now you tell us why. Remember, when it's not a function, that means there must be some time when x does not have just one y value. We just need one example. Tori, can you help them out? Are there any x values in that mapping diagram that are mapped to more than one y?
Yes.
Joss, what do you think?
I don't get any of this.
Okay, you weren't here yesterday, so I'll give you a break. Cody?
Each x value has more than one y value.
Okay, let's be even more specific. When x equals, let's just pick one
When
value.
x equals 8,
When x equals 8,
when x equals 8, 8 has two different
there
y
are
values. There are
how
two
many different y values? 1, 2,
3.
3. When x equals 8, there are 3 different, and you gotta say different because if they had the same, if those y values were the same, we would not have that would not qualify then. So be specific, pick a time, something that makes it break down from being a function. So when x equals 8, there are 3 different y values. What else could we have used as an example?
9.
When x equals 9, there are 2 different y values. Notice here, when you have x equal to 9, it is mapped to 2 different y values. So we could have used that as our justification. Okay, and our last one. What's our domain? What's our domain? 0? Go ahead, class.
0, 1, and 2.
Oh, that's a class, all right. Cody. Use your voice boxes. Range.
4, 5, 6.
And then we got Michaela. Okay, 4, 5, 6, 7, and 8. Is this a function?
No.
Okay. Why not? Okay, Cody, why is it a
Because
no?
when x equals 2 and x equals 1, each has two different y values.
Okay, so when x equals 1, or you could also use when x equals 2, there are
Two different y values.
2 different y values. So you could use either of those to be your justification. They both make it break down. Julia.
Do you want us to do that specific, or do you
Specific?
can we just write each x value?
I want you to be that specific. And when it's not a function. When it is a function, then you can do like we did right here, okay? Each x value has exactly one y value, okay? Any other questions? Okay.